You were just waiting for that. Now this is good. Right after we go live.
Yeah.
It's gonna go live. Are we ready? Let's go. All right. So good evening, everybody. Thank you for coming to the next in our series of Wednesday night TWed talks. Tonight we're going to be featuring Dominic Difranzo, the Iron Hacker, who's going to take us on a journey through the anatomy of linked open government data mashup. He's going to give us a 30 to 45 minute tutorial on the art of mashup creation. And then we hope we're going to engage in some group hacks. We already have a couple hacks in process as we speak, using some linked open government data. And we hope to be working together over the next couple hours on that. Now, we've got 4 more, including tonight's. We've got 4 remaining TWed talks. We've got the next few in the series. The Wednesday after Thanksgiving, we've got Evan Patton, who's going to talk us through reasoning. 2 weeks after that, we've got Josh Shinavir, who's going to be talking to us about real-time semantic agents. And the last one of the term is Eric Rosell, who's going to take us through applying the S2S faceted interface. So it should be the last few weeks of this term are going to be really awesome. And I encourage you to join in. So without further ado, take it away, Iron Hacker.
Yay! Okay.
And I'm sorry, one last thing for the people in the room. The pizza is going to be delivered shortly.
Should be here soon. So I know you're all really just waiting for that.
Yeah.
The moment that pizza comes in, I'm fully expecting this room to just to go off. Yeah, so today I wanted to talk a little bit about kind of the basics of some mashup creation using LOGD data specifically, but really any type of linked data at all. So I wanted to kind of discuss some of the steps of how we actually do this, kind of go in detail of how we use one of our favorite visualization tools, the Google Visualization Library. So you kind of have that library kind of on your tool belt, and you can kind of make cool and interesting visualizations very fast and easily. And then we're going to do this by going through a small example of actually building a demo live on the screen, kind of going through those steps. And then after that, in about, I'm probably going to speak for about 30 to 45 minutes. After that, I kind of want you guys to kind of play around with yourself. So take the queries I'm showing you, take some of the data sets that we looked at, take some other data sets. I can point you to some other cool places. You can try something yourself, make your own, copy and paste this code. Kind of fiddle around with it. Augment the current one, make your own. And I'll be here to walk around and kind of help you with that, and kind of give you some suggestions of next steps you can take your fun demo. So we're talking about using semantic web technologies to make applications. We're talking about you kind of wanted to get away from this model. The traditional web application model speaks about the 3 main pieces are MVC, our model view controller model that we typically see on the web. So we have our browser, that's the users are using at, and that is their connection point to the web. That's the view, so to speak, of web applications. This browser is sending off HTTP requests to some type of server. You see that in the middle there, this this dynamic content engine that's usually resting on a server. This content engine is asking a database to answer these questions. It's trying to come up with requests, try to figure out what it is the user wants, and grabbing that data from some type of database, and then mixing it up and throwing it back to the user in the form of HTML or pictures or other type of visual format. And so while this is really great, this database has a lot of limitations that we've talked about before when we talk about semantic web. It's only sitting in one place. You can only answer questions that it knows how to answer. It's not linking to other types of things. It only knows about the things inside of its own scope. It's not really a scalable way of how we want to do mashups of content because that mashup, in this case, is taking place in the actual server, it's taking place in our code that we care about. And that's really not great, because that's kind of hiding all of that mashup goodiness from others, and it's hard to reuse that. So if we could do instead, if we can do mashups at the data logic level, what if we instead were pulling from multiple sources all over the place and combining that inside of our code? What if we could actually have the data itself linked and combined to one another, so that the data and those links and that time that it took to create those links could be reused and repurposed for other people? And so that's kind of the basics of kind of what we wanted to do. So kind of the first step as we look out and try to understand how to make a mashup, what do we want to do, we need to start thinking about, first and foremost, the data that we have, and try to figure out that story, that idea that we wish to tell from that. So it's looking at outside data sets, things inside LOGD, things inside of other linked data sets from the LOD community, so Wiki, DBpedia, Freebase, GeoNames, some of the big LOD data sets, and trying to figure out what can we do with this. These different data sets, we can see the links that are already there. What are some cool options? What are some cool questions? What are some stories that can come out from the mixing of that data? And that's really the hardest part. I mean, I'm going to tell you that the actual technology, the actual steps of how to do this isn't difficult. I'm going to go through them right now pretty quickly, because there's not much there. The hardest part is understanding what the hell your data is. Where did it come from? What can you tell with this? What's the quality of that data? When you're mashing things up together, is that a really good mashing? Is that linking correct? These are the hardest parts, and this is what, personally, what I spend most of my time thinking about, mulling over, trying to understand before I ever write a single line of code.
What the hell is my data?
Yeah, what the hell is my data? And then we want to start thinking about, once we have some idea of what we have, of what is out there, what story we wish to tell, then we have to start thinking about how we're going to present this to someone else. I'm not going to go through the whole, kind of visualization theory and design. That's a whole, there's fields that study just that through cognitive science. There's even some researchers here at our lab that look into some of those questions. But trying to think of what are some of the best practices of showing this type of data. Will this look best in the map? Will this look best in the pie chart? Is this something that should have to be more interactive? Is that something that should be more static? These are questions and designs you're going to have to come up with yourself. But the best part with using some of these technologies and playing around with this is that you don't have to make those decisions right away, or they're not written in stone. That doesn't take you 2 months to get out that first map, and if you decide to change later, you've just wasted all that time. You can do that within a few hours, see if it looks good, share it with a few people, get their feedback on that, and kind of radically prototype, show other people, change things around, make many iterations, testing, etc. You should be going through the cycle thinking in terms of that, have that type of mindset as you approach these problems. So we've already had some tutorials on Sparkle, so I'm not going to talk about Sparkle per se. I'm going to kind of assume you have some understanding of the Sparkle query language. But I'm going to be talking about one of our services we have in the lab called Sparkle Proxy, and how you can use this to assist in building your mashups. So Sparkle Proxy is a web service. It allows you to query any Sparkle endpoint and get those results back from the Sparkle endpoint in any format you want. It also handles some caching for you, so that's kind of helpful. And it allows you to be able to query endpoints in a very RESTful way. And in case you're not kind of curious what kind of RESTful means, it's accessing web services similar to the HTTP protocol. So for getting content, we'd be sending GET requests, just like you would use a GET request to get a page. You can use a GET request and using the right URI and the right parameters inside of that, query an endpoint, get back something from an API, et cetera, et cetera. A lot of web APIs lately, yes?
So when you say this lets you query any Sparkle endpoint, that's like anywhere, or just the ones that are here?
Any endpoints that that are public, any publicly available endpoints. It'll acts as kind of a mediator between the two. And there's parameters inside of that to specify which endpoint you wanted to query. If you don't specify any, it'll go with the default, which is the LOGD one.
Yeah. Not all Sparkle endpoints allow you to choose what kind of output format, serialization format you want. So ours introduces this middleware, so if you want it in JSON, you want it in RDF XML.
Yeah, you can kind of get it. So that's kind of one of the reasons why we use it. Okay, so this is the base kind of URI for Sparkle proxies where it can be found. So logd.tw.rpi.edu/sparkle. If you go there right now, you will be presented with a cute little interface which you can put in your own queries. I think we've shown this a few times before. Let me actually show you. Let's do it again. So this is what you would get. So you can put your queries inside of here. If your query is located on a server somewhere and is publicly accessible through the web, you can put that URI up there instead. So you can reference a query instead of putting it down as text. And here's some of the result formats in which you can get it in. So let me actually execute a query and kind of show you. So this is one we're going to talk about later. I'll get more detail about it. But notice there's, after the little question mark thing here, what we call the parameter section of the URL, there's a bunch of stuff going on here. This is the user interface uses the same kind of RESTful API patterns that you're going to be using in your code. You can see that happening here right now. So we're going to go through and talk about what these different parameters mean, what to set them as, and kind of give you some instructions on how to use Sparkle proxy. Let's get back into that. Okay, so we have kind of two first mutually exclusive parameters, the query and query URI. So the query parameter, this is used to say that, oh, that looks like we got pizza time. Pizza time! I'm on my way. Yeah! Okay, so this is the query part is used to specify that that this query is going to be using actual text inside the URI itself. That's going to be part of the parameter. So if you wanted to, if you don't have this, I don't know if I said this. If you don't have the query, the Sparkle query on a server somewhere on the web, you just writing it in somewhere. You would actually put the physical query inside of that parameter. Or you can specify a URI where the query actually lives, and just point to that and say, my query is there. Get that query and use that one, and it'll do that for you. And of course, obviously, those two are mutually exclusive. Any questions on parameters, why they're used, what those two mean, etc., etc.? Okay, let's continue. Service URI. So this is one that specifies the service of the Sparkle endpoint service you wish to use. So if you do not specify one, it'll default to the LOGD Sparkle endpoint. Yes?
I had a question because I was just using this for our project, and I guess my question is, should that be set as the content type for REST?
The content type?
On the header, rather than...
Why would it be the content type? In terms of, you mean the
I guess the really...
you mean the service URI should be the content type? Or
No,
the output?
the output type that you're asking for, I think in REST is set in the header rather than in the
Yes,
header.
you can set it in the header and stuff like that. We do that mostly because it's a little easier programmatically to put things in parameters URIs than to create the HTTP headers themselves. Because most language, I mean, you could do that in every language. You could set the headers yourself, but it's a lot easier to just say .get this thing and just do a normal GET request.
Yeah, and the only reason I was asking about that was that the problem I was running into was evidently the architecture that I had, has a 256 character limit on a GET.
Oh, interesting.
Because it's like a spec.
Oh, yeah.
So the URI thing was super exciting because you could just point to the query and say, here it is, and you could keep it inside the specifications of the web.
Yeah.
But I was getting, I don't know, I was like, oh my god, how can I shorten this up so I can keep it legal?
Yeah. That's interesting. No, I've never experienced any problems with the character limit. So like you can actually put the queries inside of the URI itself, and those are huge. They're really big. Huh. I've never experienced any library or anything like that. Of telling it's too big.
No, like a library, no, like routers.
Oh, really? I have not experienced anything like that. There's the 20 character limit for URLs?
I'm sorry, 256 or whatever.
256. I wasn't aware there was a limit on that in the official specs.
Obligated to forward rather than that. Interesting. Our router in the VCC was like, no.
Oh,
In
wow.
the library, PHP let it through, and then it bounced at the router and came back, and I was like,
Wow, I've never experienced
so I
that. It's
posted
really
that,
odd.
so I
Yeah.
could- yeah, anyway, that was...
One of the other reasons why is we also have some specific content types that aren't really feel like that. So like we have one that's like made just for Google Viz. That's not a standard V type. You know what I mean?
Yeah.
And other things like that. So it makes it a little easier.
Sure.
So yeah, for the service parameter, this is where you tell the service the endpoint. So if you wanted to query DBpedia, that's dbpedia.org/sparkle. That's their endpoint. Or you can, if you want to do any of ours, you can specify the URI there. Like I said, if you don't specify one, that's okay. It'll just default to the LOGD one. The output one here, like we were just talking about before, the content type that you're going to return back is actually parameter in the URI. And these are the different legal parameters you can give it. So XML will give back Sparkle XML. Exhibit will give back a JSON file that works for the MIT Simile exhibit fast in the browser. They like their JSON in a certain format, and it makes it easier to just have our results turn back in that rather than converting into it. Same thing with Google Viz, because we use Google Viz so much, we like it so much. We made a special output type or output format just for Google Viz. Same thing was you get in CSV, you get in HTML, or you get in Sparkle, which is Sparkle JSON, which is kind of a pseudo-standard of Sparkle results for JSON. Any questions, any comments, any concerns? Yes, in the back.
Please explain what service URI?
With the what?
Service URI, what's that?
Yeah, the service URI is where you specify which Sparkle endpoint you want to Sparkle, or you want to query against. So if you want to query DBpedia, inside of this you would put service URI equals HTTP dbpedia.org/sparkle. If you want to do any of ours, if you want to do LOGD, you can just keep that empty because it defaults to the LOGD Sparkle endpoint. But if you want to do the data.gov one or the Orgpedia Sparkle endpoint, et cetera, you put those. You put that where you find that Sparkle endpoint inside that parameter. Okay. Any other questions, comments, concerns? Okay. Cool beans. So here's a quick example of why you really cannot see those colors at all. They come out super shitty. And I apologize for that. Can you see my mouse here? Okay, cool. So here we see a quick example of what all this junk looks like together. So here we see we got logd /sparkle@php. Question mark. This means after this is the parameter part of our URI where all of our cool little parameters go. So saying query, I didn't talk about, oh, dang it, I don't click on it. Okay. I didn't talk about this one, but it's kind of important as well. You also have to, there's a parameter to specify what the query option is going to be. So it's either text, in this case the URI, the query part is going to be part of inside of the URI itself, like this, or it's going to be URI. In that case, you're going to be specifying a query URI inside of this parameter. I forgot to mention that one, but it's fine. So here's the actual query. Notice how it looks. This is an actual Sparkle query, but it looks all crazy. That's because it's formatted for the URI for URI formats. So you can't have obviously in URI you can't have spaces. There's certain special characters that aren't allowed. So you use the URI encoding to encode all that, and that's why it looks all like gobbledygook. But it's just a Sparkle query. Service URI was set that as nothing because we wanted to Sparkle the LOGD endpoint. Output, we had to set as HTML because we want this to come back as an HTML page. There's a couple other parameters I'm not going to talk about because it doesn't really concern us for the moment, but you can look into them more if you look into the Sparkle proxy documentation. I can talk really quick about it. Callback is if you're working in JavaScript and you want Sparkle proxy to call back JavaScript function for you. As you wait for things to go on, you can do that there. You specify the function of which you want it to call back on. This TQX is used for, it's a numbering system that Google Viz uses when you want to do multiple queries, so to keep track of which queries are going where. Where you should be using like a callback, but they don't use it. They have like their own little weird wonky thing. And since we have a few queries that do multiple queries inside of a single Google Viz.
I'm sorry to interrupt. Did you show how to generate this?
Yeah. What do you mean how to generate this? I talked about. I discussed all the parameters.
So, I know, but you should. This is the spew that Sparkle proxy gets. Right from you put a query into Sparkle proxy.
You generate. If you're working in code, like you were like we're supposed to be doing, like good people.
But that's a nightmare.
You have to make that. No, but you use URL and code like almost everything.
Well, show them how to do that.
I will. There's examples coming on after the fact. And TP, I don't remember what TP does off the top of my head. I think it's another. There's another rail. I think it's something like a clear the cache or something like that. So a quick example in PHP of how to Sparkle, how to use Sparkle proxy. So notice we have Sparkle proxy listed. Next, notice the URI looks a little different. It's because that's the actual, that's where Sparkle proxy actually lives. You specify the Sparkle proxy URI. You start building some parameters. First parameter, query URI. We give it the query URI which we want to Sparkle. So if you were to go to this page, if you were to put this in your browser, you will see the Sparkle query. And that's the one that this endpoint will not be Sparkle yet. This is the service URI. This is the actual Sparkle endpoint which you query. GBDS, and you want our output as a Google Viz JSON object. And then we're putting it all together. So first we start, look at a little parameter. First we start, of course, with our LOGD thing. Question mark, very important. Because then we're going to make our parameters. This thing right here, build HTTP query. It's a nice inside PHP function that will build URL queries for you by specifying an array. So it's really easy. So you just kind of copy and paste this. And then you make sure you want it to be, you want each one to be separated by an ampersand because that's how we separate parameters and URLs. And then we do, files with contents. And this says a GET request. This is HTTP GET on this whole URI which is created, and we'll get back this function will return back the JSON object of which we cared about, which will be the result of that query. Any questions?